Section 5.4, Predicting Chemical Reactions. Products of chemical reactions are identified experimentally, but we can make predictions for 5 types of reactions. I'm going to go through each of the 5 reactions and represent them with paper models. First, decomposition reactions. In this type of reaction, a substance simply breaks down into simpler parts, like this. Here's an example of a combination reaction. Simple substances combine into more complex substances. A common reaction are between metal and nonmetals to form ionic compounds. Here's a representation of a single displacement reaction. An element replaces another element from its compound. For example, the blue will come in and replace the red. You can consult the activity series chart to know whether this will happen. On page 177 of your text, you'll find figure 5.21. This is the activity series. The most active elements appear at the top. The most active elements will replace other elements and a single displacement reaction will occur. In a double displacement reaction, 2 compounds actually exchange partners. This reaction occurs if a precipitate occurs, which is a solid, or if an insoluble gas forms, you can notice this by bubbles, or if a stable molecule like water forms. A combustion reaction is when substances react with O2 or elemental oxygen. This often produces heat and flames. In the combustion of hydrocarbons, the products are always water vapor and carbon dioxide. Let's try some example problems. I'd like us to balance each reaction and then identify the type of reaction. Let's begin with the first one. I first need to start tallying the amount of atoms on either side. Now my next job is to count up on the reactant side how many I have, as well as how many I have on the product side. Notice I can keep my polyatomic ion together. Here I finished counting. I am done balancing the equation. Now my next job is to figure out what type of reaction this is. Notice that the calcium is with chlorine here, and now the calcium is with carbonate here. It's some type of displacement. Also here, the potassium is now with the chlorine. This is a double displacement reaction. Let's look at the second example. First, we need to balance the equation, and then second, we'll decide what type of reaction it is. What type of reaction is this? Well, my zinc is now with chlorine, and my hydrogen is now with sulfur. This is another example of a double displacement reaction. Here's another example. What type of reaction is this? I have 2 substances combining. It's a combination reaction. Here's another example. Hydrogen peroxide yields H2O and O2. Notice there is a heat above this arrow. Let's first tally it so that I can balance the equation, and then we'll figure out what type of reaction it is. Here's my tallies. I have a substance breaking down into simpler parts. This is a decomposition. Let's try this one. Let's first balance it. It actually is already balanced, so we were lucky. Now I need to decide what type of reaction this is. I know that I have 2 substances combining to create one substance. This is a combination reaction. Here's another example. First, I counted them up, and now I need to balance. Aluminum, I need 1 more aluminum over here. Let's try a 2 right there. Now iron. I need 1 more iron over here. Let's put a 2 right there. Now I'm balanced. What type of reaction is this? It looks like aluminum is replacing the iron. It's kicking the iron out. So then iron is alone over here. That is a single displacement reaction. Here's another example. It looks like I am balanced. Now what type of reaction is this? It looks like chlorine is then combined with sodium, as well as hydrogen combines with this OH to create H2O. That's an example of a double displacement reaction. Finally, the last example. Now I'm balanced. What type of reaction is this? This is a single displacement reaction.